Hello, you're welcome. All right, so now the topic before us is variation. Okay, so what is variation? Now, variation, okay, in mathematics is actually a mathematical statement, okay, or a mathematical relationship between two variables, okay, that can be expressed by an equation in which one variable is equal to a constant times the other variable. So a variation is a mathematical relationship between two variables that in such a mathematical relationship, okay, the two variables are related in such a way that one variable is equal to the other variable times a constant. So variation will always introduce a constant multiplied to a variable to make it equal to another variable. Okay, for example, if I say that A varies, okay, with B, okay, so it's something as saying A is equal to B, okay, then times a constant times k. So that is the only way, okay, the condition of variation can be satisfied. Okay, that is just by the way. Okay, so now mathematical sign for variation is this, so we use this for variation. Example, if A varies directly with B, as I already said, it's gonna be, okay, so for me to actually change the variation sign into an equal to, I must introduce a constant. So that is how we express variation. Okay, variation of different types, and we're looking at different types of variation. Okay, number one, we'll talk about direct variation. Okay, direct variation. We'll talk about, okay, inverse variation. Then also we'll talk about joint variation. Then we will talk about finally partial variation. Okay, so these are the different types of variation we're gonna handle. Okay, and of course we'll solve question, okay, on them. So starting with the very first one, direct variation. Direct. So now when two quantity actually varies directly, okay, when two quantities varies directly, say they varies directly, simply means that those two quantities are related to each other in such a way that if one increases, the other one increase. Okay, if the one decreases, the other one decreases, vice versa. Okay, for example, if I say x varies directly with y, it simply means that when the value of x increases, okay, then definitely value of y will also increase. So that is called direct variation. All right, so now know one thing about variation. Okay, if you want to evaluate variation, okay, as okay, let me use this same example, x varies as y. For me to be able to solve variation, I can't use variation sign or proportional sign. Okay, I have to change that variation sign into an equal to. All right, then once, if I should change it to an equal to, I will introduce a constant. So now anytime you're being asked to solve variation, the very first thing you need to find is that constant. Okay, you need to get the constant. Of course, the constant here is going to be x all over y. So everything boils about, because the relationship of the two variable is actually, okay, dependent on the value of the constant. So the constant is the very first thing that one should actually get. The constant is the very first expression. So now let me give an example. Okay, let's say let's call a question where they said, okay, if x varies directly as y, okay, then when x is equal to 4, y is equal to 2. Okay, y is equal to 2. Then the question now is find x, okay, when y is equal to 8. Alright, so it's very simple. The very first thing you need to do in solving the question of variation is to write the statement of the variation. Okay, so we say that x varies. Okay, in most times this varies, they will write it in word, but you know that this is the variation. S varies directly as y, so directly as y, that means this is how I write it. Then of course you know very well that if s varies directly as y, s is going to be equal to ky, right? And of course for me to get the k is going to be equal to x all over y. All right, so the k is actually s all over y. That's the relationship. So the very first thing now is now go to the value that was given when s is equal to 4. So I put the value s is equal to 4, then divided by y is equal to 2. So I need to get the value of the constant, because you need to get the value of your constant before you now solve the question, right? So s is gonna be k is gonna be equal to s all over y, which of course is 4 over 2, and that is 2. So having gotten the value of the constant now, then what am I going to do with it? Okay, I can now solve the question. So what's the question? Say find x when y is equal to 8. So find s, remember s is equal to ky, so find s when y is equal to 8. Having gotten the constant, remember s is equal to ky, right? Then x is going to be equal to k is already 2. Then we are told that y is 8. Okay, so that's going to be 2 times 8, which is 16. Okay, that is the rate variation. I hope that is well understood. Okay, I'll be picking some questions, right? Let's see another question on the rate variation. All right, okay, so I have a question here. It goes this way. I bring it up. So the question goes this way: if v varies directly as the square root of t, v, I write it, varies directly as the square root of t. So don't forget that I have to introduce a constant. Okay, this is going to be equal to the square root of t. Okay, so and of course my k is going to be equal to v divided by the square root of t. So let's go there. So we are told that when v is equal to 2, t is equal to 4. So when v is equal to 2, t is equal to 4. That's going to be square root of 4. So that's going to be 2 divided by square root of 4 is 2. So that means k is equal to 1. So I've gotten my k. So I now find, okay, so what am I looking for? So the question now, find v when t is equal to 16. Okay, so find v is going to be equal to, of course, k, which of course is 1, multiplied by the square root of t, and of course that's 16 given there. So that's going to be 1 times the square root of 16 is 4. So v becomes equal to 4. So take note of that. Let's pick another question. All right, or we talk about the next variation. Okay, we'll solve more questions, but let's talk about the next variation. The next variation is, of course, is joint. Is we have direct variation. Okay, we have inverse. Okay, I hope that's what I actually wrote. Inverse variation, direct variation, inverse variation. Please, if I make a mistake, just inverse variation, right? So in inverse variation, look at how we represent inverse variation. We use reciprocal. If two quantity varies inversely to each other, they use a reciprocal to represent the variation statement. For example, if I say that x varies inversely with y, it simply means that x varies, the word inverse means inverse of y, 1 all over y. So that is how, so this shows inverse variation when you write it in terms of a reciprocal of the expression at the right hand side. Okay, and the same process, okay, goes through. Of course, I changed the sign of variation, and then I need to introduce a constant. Okay, so in this case the constant is equal to k all over y. So if I want to get k, I have to cross multiply, right? So k becomes xy. So that is so in inverse variation. And of course, what is the implication of inverse variation? If two quantities inversely varies with each other, when one increases, the other one decreases, vice versa. So let's look at some questions that illustrate inverse variation. Okay, so I have a very simple question that I want us to do justice to. So this goes like this. Okay, so here I have this. Okay, so question: if p varies inversely as v, so p varies inversely as v, so that's how you write it. So that simply means that p is equal to k all over v. So that makes my constant now to be equal to p multiplied by v. Okay, so which simply means that k now is going to be equal to p. Alright, and p, the value of p given initially, initial value, we get our k from the initial value that was given. The initial value of p was 3, then times the initial value of course v is 6. 3 times 6, this gives me 12. Okay, so having got to my k, and I can now find what get what I'm looking for, right? So the question is find p when v is equal to 8. So find p, remember p, okay, from the expression we had here is k all over v. Okay, so having gotten the k to is 12, then of course v, we are looking for p when v is equal to 8. That's gonna be this. So p now becomes okay, 8 over 12. Something will break it down, of course. 4 breaks 12, divide 12 I have 3, then divide 8. Okay, 4 divide 8 I have 2, right? Which of course that should be 1.5. Alright, okay, so please take note of that. Then we now go to the next type of variation, which is joint variation. Now the word joint is made up of combination of two variation, right? When you use and in the variation, when the same quantity varies with two different quantities called joint, it is jointly varies. For example, if I say that v varies inversely as p, then I say and the same v varies directly as t, this is called joint variation. So v varies with two different quantities at the same time. So now to combine the two variation, I can simply say that okay, v varies inversely varies with 1 over p, then times. So for joint variation we use multiplication, okay, then times t. So v varies as 1 over p, then times t. So I can actually not need to use, okay, well shit, I can't do that. Of course, the same thing happens here. I need to bring an equal to, then introduce a constant. That's gonna be kt divided by p. So you know what happens in this case. All right, I need to get the value of the k, of course, by cross multiplying, right? Kt multiplied by 1 is kt, p multiplied by v is pv, right? So t is gonna be, oh, okay, please pardon me. So the value of my constant, okay, k, is gonna be equal to pv divided by t. Okay, so that is it. Let's look at a question that actually illustrates that. Okay, okay, so I have a question that is similar. Okay, so I have a question that's similar to what. Okay, so clean up. So I have this question goes like this: given that v varies, okay, directly with t, and at the same time, and v also varies directly with 1 over inversely as p, or directly as 1 over p, still the same thing. Okay, so So the question is, when v is equal to 2, t is equal to 4, p is equal to 8. So first of all, let's create the relationship. That simply means that v is equal to, okay, k, then of course kt all over p. So I need to get this constant because that is what will help me to get anything I want to get, okay? So of course the constant, if I cross multiply, the constant is going to be pv, of course, divided by t. I've done this before. So we are now given the initial value. Let's put the initial value, okay, into the expression. Then when v is equal to 2, t is equal to 4, p is equal to so here p is equal to 8, right? At that instant v is equal to 2, then divided by t is equal to 4, so I'm having 16 all over 4, okay? And of course 16 all over 4 is what? 16 divided by 4, that should be 4, right? Yep, 16 divided by 4 is 4. Okay, so if that now be the case, okay, of it, I've gotten my k. So now let's now get to solve, because once you get your k, you get to solve the question. So the question, find the relationship between v, t, and p, is very simple, okay? Already the relationship between v, t, and p is giving us from the formula v is equal to k t all over p, right? So this, the k I've actually gotten, so that means v is equal to 40, all right, then all over p. Okay, so variation is just a very simple topic, all right, and we are going to look at more questions. Then we'll look at partial variation, then we'll solve question. Okay, so just take your time and go through this, then we'll continue. Right, see you in the next video. Thank you.